In this video we're going to talk about correlation and regression and how you do it in Excel. At least the simple, some of the simple functions, the correlation function, the slope function, and the intercept function. Alright, so here we have a set of 10-year-olds. You can see their age is 10. And we have some various data points on their various eye characteristics. And we have several classifications of refractive status. On sheet 1 here I've put in the name 0 is extreme myope, 1 myope, 2 emmetrope, and so forth. Now what we first want to do is we want to look at the correlation between spherical equivalence and relative peripheral refraction. So let's come up here and let's say equals, and let's do a correlation. And we've got our function, correl, and it shows up down here, so we can hit the tab key and it tells us we need array 1 and array 2. So making sure we're on line 2 there. Actually, I haven't frozen the pane, so it's probably not going to be an issue. So we'll hit down, arrow, a comma, and then come back up. And then array 2 is relative peripheral refraction. Control, shift, down arrow. Now notice here we have a blank, so we got to be careful about that. This was missing data. Now Excel will ignore it, but we have to get around it. So we'll come down to here, Control Shift down arrow. Definitely something to watch out for. And then we hit close parenthesis. Come back up here. Maybe it doesn't ignore it. Okay. Alright, doesn't ignore it. Let's sort by relative peripheral refraction. And come down to the bottom. Oh, look at all those nulls. That's what it doesn't like. It doesn't like those words. Now let's go back up here. Null is a symbol that is used for missing data when we transfer the data from SPSS. I have this original file in SPSS. So the correlation is minus 44493. Now let's do something a little bit more interesting to come and find about if the correlations are the same between groups. And to do this, we're going to hire a little aid. I'm going to go over here. Well, let's come up along here, highlight these. You don't really have to highlight them, but let's click on the filter. Notice how that puts in this little down arrow sign. So let's go to last refractive status. Let's sort smallest to largest. That puts everybody in the order, so extreme myopes are first. And then let's click on this select all, so everybody is unselected, and then let's pick out extreme myopes. Notice the color of the numbering over here is changed to blue, and it only shows 36 subjects. It starts counting at 1, so it's 37 minus 1. Now, this is all of it. It's only illustrating last refractive status equals 0. And now let's do a correlation. Let's put here extreme myope. And let's do Pearson R. That's our correlation. It's called Pearson's correlation. And let's equal correl. There it is. We got 3 letters. Hit tab. do spherical equivalence, comma, comma, relative peripheral fraction, close parenthesis, and here we have minus 0.3. So overall, correlation is minus 0.44, but for extreme myopes, it's minus 0.3. Now, remember that our formula is y equals a plus bx. So y equals a plus bx, where anyway, so a is the intercept and b is the slope, so we need an intercept. And that's going to be equals INTE, there's the intercept function, tab, and known y's. Now, I want to use relative peripheral fraction to predict spherical equivalence. So, known y's would be spherical equivalence. So let's put that there. And a comma. And the x's are going to be here. And we will close the parentheses. And so our intercept is minus 2.4. That means when relative peripheral fraction is 0, it crosses the y at minus 2.41898. So that's the intercept, is the point where x equals 0. The intercept is the y value when x equals 0. Now let's do the slope. And equals S L O, and it's going to be a tab, and the known y's, again our spherical equivalence, comma, and the x's are relative peripheral fraction. Close parenthesis. And so here's our thing, hit enter, and we get minus 3.8. So that means for a diopter change in x, in the relative peripheral refraction, as relative peripheral refraction increases by plus 1 diopter, spherical equivalence decreases by minus 0.38 diopters. So it is the change in y, minus 0.38, for the unit change in x, relative peripheral refraction. And unit change means a change of 1. All right, so we have computed for the extreme myopes. Now we can come up here to last refractive status, click on our little filter, and say, okay, we don't want 0, we want 1. Okay. Now it has given us the refractive status of 1. There's a lot more of those. 260. And we can do this. Now, notice we're on row 38. So our previous Pearson correlation coefficients are up at the top here. So we can't see them right now because we've selected these rows, but we'll see them after we are done. So we can just try this again. But basically, this is something that you can work out for each one of these. Well, let's do the correlation equals correlation tab. And again, we want spherical equivalence, comma. Now I'm starting on a blank because I got to have everything even. So if we started up here, the first non-blank, we would be off on our correlation. They have to be matched. And close the parenthesis, and there we go. Minus 0.32. Now, let's come to our last refractive status. We've chosen that one. Let's select all. Say OK. And now we've got our extreme myopes again. And if we scroll down, we're going to have our myopes. And notice this correlation is minus 0.32, and this one is minus 0.38. All right? So that's how we do correlation, slope, and intercept.